Good morning, fourth grade. So this week we have been exploring how natural resources are put to use. Yesterday, you watched a video of me using natural resources like rock materials, water, and air to make concrete. We are letting that concrete dry for about 48 hours. So while we are waiting for our concrete to dry, we are going to read in our FOSS textbook how concrete is made. Also, at the end of the video, I will be showing you guys an update on how the concrete is looking. If you would like to read the Making Concrete by yourself, you can also go to the FOSS website, which is www.fossweb.com. Log in using the username Esperanza Science, password science, the number 4, me, and go to the interactive student ebook. We are going to be reading pages 60 to 63. You can also find the login information on Google Classroom under resources. If you would like to read along with me, let's get started. Making concrete. Concrete is a rock-like construction material that is made by people. You have probably seen a lot of places where concrete is used. Many highways are made of concrete. Bridges and overpasses are often made of concrete. Dams and stadia are made of concrete. What is concrete? You might see cement trucks at construction sites. They should be called concrete trucks because the material they carry in the big round container is actually concrete. Most modern concrete is a mixture of Portland cement and aggregates. Aggregates are pieces of rocks of different sizes. Small aggregates include sand and gravel. We added aggregates of sand to our cement mixture yesterday. Larger aggregates include pebbles of several sizes. Portland cement is a fine gray powder made from limestone. Limestone is dug out of a quarry. Then it is heated in a high temperature in a furnace and ground into fine powder. When Portland cement is mixed with water, it makes a sticky mud-like mixture. Over time, the cement mixture cures or hardens. The mixture changes into a solid hard lump. Cured cement is as hard as a rock, kind of like our experiment from yesterday. The cement mixed with our aggregates of sand and water is now getting into a hard piece of solid, and we will see how it looks so far. Concrete is a mixture of gravel, sand, cement, and water. Please open up your journals to page 30 and right under the focus question, add this vocabulary to your book. Concrete, a mixture of gravel, sand, cement, and water. Concrete uses these 4 natural resources to be able to build houses, different walls, bridges, and even our school buildings. You will now have about 2 minutes to finish adding this to page 30. Right below your focus question, write the definition for concrete, a mixture of gravel, sand, cement, and water. Now, in order to take full advantage of this property of cement, aggregates are added to the sticky mixture. The cement bonds the pieces of rock and sand, cementing them together into one strong mass. The mixture of cement, water, and aggregates is a thick fluid that can be poured into different forms. The big container on the back of a cement truck is always turning round and round. Have you seen like a cement truck like this with that big circle around that's always spinning? The motion keeps the concrete moving around so it won't harden inside the truck. Cement trucks usually don't travel very far from the plant where they load up with ingredients. Many contractors require that the concrete be poured within 90 minutes after loading, because if the concrete hardens in the truck, it might be necessary to use jackhammers to break up the concrete. Foundations for buildings are made by pouring concrete into the forms. When the concrete foundation is cured, the building is constructed on top of the foundation. This is an example of how natural resources like rock and water are used in our everyday life. However, the use of concrete for roads, buildings, bridges is not new. Concrete was invented and used widely by Romans more than 2,000 years ago. The Roman Colosseum, built in the year 70 BCE, is the largest colosseum in the world and is still standing. Concrete harbors built about the same time in the Bay of Paluzzi near Naples are still strong. They have withstood battering with ocean waves and tides. They have endured countless earthquakes for 1,000 years. Modern concrete harbors constructed using Portland concrete last as few as 50 years. Why? Why the big difference? The difference is how the concrete is made. A team of scientists and engineers, led by professors of civil and environmental engineering at the University of California, Berkeley, studied the concrete in these old structures. In 2013, the team leaders, Marie Jackson and Paulo Monteiro, announced the results of their analysis of the Roman concrete. Why do you think the concrete used for the Roman Colosseum has lasted so long? They knew from historical records that the Roman engineered concrete contained slightly different materials than the modern Portland cement concrete. Roman concrete used baked limestone similar to the Portland cement, but it used locally available volcanic ash called pozzolan. The pozzolan seems to be the secret ingredient that makes the Roman concrete so strong and durable. Remember when we talked about volcanic eruptions and how when that lava erupts and hardens into the ground, it comes into a type of rock? Back when the Colosseum was being built, they would often use that ash material to make into the concrete, and it made the cement much more stronger. The researchers also discovered that the Romans converted the limestone into lime by heating it to a much lower temperature than 1,450 degrees Celsius needed to produce Portland cement. The cooking part of the cement making process is important. It is important because it takes more fuel to generate the heat to convert limestone into Portland cement. The greater the amount of fuel burned, the greater amount of greenhouse gas produced as a waste product. Using the Roman formula for converting limestone to lime requires less fuel resulting in less CO2 released into the atmosphere. The potential engineering advantages presented by these discoveries are huge. The new way for making concrete can produce a stronger building material. Structural engineers can use it to design a safer, stronger buildings, bridges, wharves, and roads. Concrete manufacturers will be able to use less energy to convert limestone into concrete grade lime. The Roman concrete recipe will save energy and reduce the amount of CO2 going into the atmosphere. And the large deposits of pozzolan are available around the world. What type of concrete do you think is better? Roman concrete or modern concrete? Now I would like to give you an update of what our concrete that we've been working on looks like so far. This first picture, the picture on the right, is what it looked like last night when we first poured it into our mold. This morning when I checked on it, this is what the concrete is starting to look like. When I touched it, it was still a bit bouncy. It was not that hard, but we will check back in tomorrow to see what it looks like. How do you think the concrete will change by tomorrow?